And it turns out that if you want to address these effectively, one tool that you can use is mechanism design. Now, the reason why you would like to use mechanism design is that the agents involved here or the crowd workers involved here could be very strategic. They hold on to some private information. They will not reveal the true quality of performing the tasks and so on. So you will have to, you are confronted with incomplete information. And it turns out that if you really want to effectively and scientifically design protocols for making crowdsourcing more effective, you need to use game theory and mechanism design. Okay, so I will try to say what mechanism design is and how mechanism design is going to help in designing the kind of crowdsourcing mechanisms that we have just now talked about. So in a mechanism design context, you are given a set of utility maximizing agents with private information. So you have human beings or you have strategic players. They have private information with them which they may or may not truthfully report, and they strategize because they have a utility function. All the time they are trying to maximize an expected value of this utility function, and the utility of one player could be conflicting with the utility of another player, and the utility that is going to be gained by a player will depend on the collective actions of all the players. So if you are given a set of such agents, and now you would like a social choice function that captures desired social properties. So you would like to implement a so-called social choice function. So this social choice function captures social welfare of the system. Now if you want to do that, then if you let these players play according to their utility maximizing actions, it may turn out that instead of maximizing the social choice function, you are actually minimizing the value of the social choice function, because there could be conflict in the utility objectives of the players, right? So mechanism design is all about implementing a social choice function which captures desirable behavior of the entire system in spite of the strategic behavior of the players who are involved in this particular game. So mechanism design, it will induce a game on the various players in a way that in an equilibrium of the game, the social choice function actually gets implemented. So let me give a simple example here, and many of you might be familiar with this example. So this is the classical cake cutting problem. So here the social planner or the social designer is a mother, and you have two strategic players here. These are the two, a son and a daughter of this mother, let us say. And what is to be shared by these two kids is a cake. I do not know if it looks like a cake. I think it looks like a cake. But the idea here is to ensure that this cake is equally shared between these two kids. So now one way in which you can actually design a protocol here is the mother takes the best possible knife and then slices this cake into what she thinks are two exactly equal portions, and then each of the sons or each of the kids will pick up one of these slices. Now in this solution, the problem is that even if the two slices are exactly of the same size, each child will go away with the feeling that the other child got the larger of the two slices. So the children are not going to be happy with this kind of a solution. And also the mother has to take the best possible knife and then has to apportion that into two pieces. So now in a situation like this, you can induce a very simple game on these two players here, in this case the two kids, which will actually realize a social choice function, implement a social choice function. So what is this protocol that will enable this? So mother is now the mechanism designer or the social planner, and what the mother does is to say the following, She gives the knife to the first kid and tells the first kid, you must now slice this into 2 portions. And the other kid will get the chance to pick up one of these 2 portions. Right? So now both these players are utility maximizing. What does the first kid do? The way the first kid will think is, I am going to slice this into 2 portions. Now the other kid is going to take the larger of the 2 portions. If I do not want the larger portion to go, I must slice it into exactly 2 pieces. Right? So the first kid is very happy now. The second kid is also very happy because the second kid first of all has got a chance to pick up one of these 2 slices, and she will pick up what she thinks is the larger of the 2 slices, though they are actually equal. Right? So using a very simple protocol which has induced a game between the 2 players here, the mother, the social planner, is actually able to solve a very interesting problem. So then the second example, which is the famous Vickrey auction, will tell us how you will be able to actually induce truth revelation by inducing a game among the players. So what is the Vickrey auction? It is also called as the second prize auction, and William Vickrey received the Nobel Prize in 1996 for this brilliant idea. It's a very simple idea. It's an auction where you are trying to sell one single indivisible item, and there are bidders. And in this particular case, assume that there are 4 bidders whose bids are 40, 45, 60 and 80. So these are the bids of the 4 players. Now in the usual auction, which is called as the first prize auction, what is done is the item is actually awarded to the bidder who has bid the highest. In this case, bidder 4 has bid the highest. So he will be awarded the item, and then how much does he have to pay in the first prize auction? He will have to pay 80 rupees in order to get this item. But Vickrey did a very small innovation there. It's a brilliant idea. He said that the item will be awarded to the bidder who has bid the highest, but the winning bidder is going to pay an amount not equal to his bid, but equal to the second highest bid, or the highest losing bid, or the second highest bid. And using very deep game theory, William Vickrey was able to show that this will actually reveal, this will make all the players to bid their true valuations. So what do you mean by true valuations? So if you have an item, so let's say there is a camera that you're trying to buy. You have an implicit valuation for this camera. Your valuation for this camera may be, let's say, $80, right? And somebody else's valuation may be $60 and $45 and $40. So when you are asked to bid in a first prize auction, you will never bid your valuation. You will not bid $80 because you know that your valuation is $80, and then by paying $80, your utility actually is going to be 0. Fine. So what William Vickrey did was to say that you are not going to pay what you have bid, but you are going to pay something less than what you have bid, which is equal to the difference between the bids of the highest and the second highest bids. And by writing down the underlying game, he was actually able to show that it is a strongly dominant strategy for each player to bid their true valuations. They will bid their true valuations now because they certainly want to win the item, and they also are able to bid aggressively because they know that they are not going to pay what they have bid but something less than what they have bid. And if what they are going to pay is less by the difference between the highest bid and the second highest bid, Vickrey actually showed that it becomes a dominant strategy. So another application which generates most of the revenue for all the search engines is this internet advertising auction. A search engine like Google has the so-called keyword auction. So if you type in a keyword like Christmas, which is not far away, then on the left side you get a very large number of organic links, and on the right side you get a stack of advertisers. And when a user who is doing a search on this keyword clicks on one of these slots, So that user or so that advertiser corresponding to that will end up paying a certain amount of money to the search engine. And it turns out that these auctions come in various forms and varieties, and Google actually makes 90% of its revenue only through auctions of various kinds, such as this. If you want to design this auction so that Google will maximize its profits or maximize its revenue from all these display ad auctions or keyword auctions, it turns out that mechanism design plays a very important role. So in some sense, mechanism design is the science behind auction design. It is the science behind market design, and it is the science behind extracting truthful information from the various players. And that is going to be extremely useful to us in crowdsourcing mechanisms. So in the interest of time, let me not go through this proof. Now, this slide basically tells you how you can formulate the victory auction as a strategic form game. So it has the bidders. So the players will be 1 to ... n. So in this case, there are 4 players. And then all of them have valuations, 40, 45, 60, and 80. And they also have strategies. So what are the strategies here? The bids that they are going to place on this item are going to be the strategies. So you have S1, S2, so on until Sn. And then what is the allocation here? The highest bidder will get the allocation. And what's the payment here? Highest non-winning bid is the payment. And what are the utilities here? For example, if your valuation is 80 and you are paying only 60, what is your utility? 80 minus 60, which is equal to 20. So that's how the utilities are defined. So you will see that this will essentially tell you how to define an underlying strategic form game for the victory auction. And using simple equilibrium analysis, you can actually show that victory auction is truthful. In fact, it turns out to be what is called DSIC, dominant strategy incentive compatible. What dominant strategy incentive compatible means that whatever is reported or whatever is bid by the other players, it is always a best response. It is always good for you to bid your own true valuation, right? It's actually, in some sense, it is just Satyameva Jayate, that's all. You don't have to worry about what the other players are doing. All that you have to do is to bid your true valuation, and that is going to be your best response. If you want to now induce a game where reporting your true valuation becomes your best response, right? That is all mechanism design is all about. So mechanism design will essentially induce a game among the players so that something which is required socially or a social choice function gets implemented in an equilibrium of the game. In this particular case, it turns out to be a dominant strategy equilibrium. So there is another equilibrium called the Bayesian-Nash equilibrium, which says that it's a best response for you to bid your true valuation whenever the rest of the players are also bidding their true valuation. So if it happens that the rest of the players are bidding their true valuations, then bidding your true valuation is a best response for you. So this is a much weaker notion of incentive compatibility in game theory, whereas the dominant strategy incentive compatibility is very, very strong. You have to just bid your true valuation without worrying about the strategies that are going to be adopted by the rest of the players, and that's the best that you can hope for in mechanism design. And victory auction actually achieves this unique characteristic. So so this was so this essentially proves why the victory auction is dominant strategy incentive compatible.